Hey everyone, welcome. Glad you're here. My name is Ryan Welch. I'm a federal director here at Claroty, and I've been working in defense critical infrastructure for a good part of my career. I actually was an Air Force officer, worked for what's now Space Force. Got to do quite a few cool things throughout my career, and yeah, excited to be with you. Today I'm going to just be having a quick talk. We're just going to talk about part one in a two-part series of how do we protect defense critical infrastructure, looking at it from an assessment framework. So normally I'd like to just, be freehand and draw this on a board, but since we don't have a board, I have a couple slides that I want to share with everybody, kind of walk you through part one of a part two on how do we protect defense critical infrastructure. So the first slide on here is really just what is defense critical infrastructure. So if you think about defense critical infrastructure, a good way to visualize it is a military installation. So in a military installation, you have power, you have water, for the air. If it's an Air Force installation, you might have planes. Those planes need fuel resupply. You have airfield lighting. You have buildings of national security on installation. And there's a lot of different pieces and parts that are needed to operate, maintain, and sustain our military forces, in the United States and different places around the world. So all these systems are what make up the critical infrastructure. Many of them are run by computers. So today I just want to talk to you about what is a framework that you can get after to really assess how to protect these networks. So part one is really focused on how do we assess these networks. So the problem with critical infrastructure, I think it was best summarized by General Chance Saltzman. He's the Space Force commander, and he noted an attack against satellite ground infrastructure that was able to take out satellite communications. So in this case, Russia was attacking ground infrastructure to take out satellite communications for troops in Ukraine. And they were able to achieve this desired effect on the military infrastructure by going after the critical infrastructure that was on the ground. And so the critical infrastructure often can be a target for these cyber attacks that enable the adversary to accomplish some desired effect against the system in a contested space. So the problem often starts with, what is the adversary trying to achieve? So if you're looking at what systems should I focus on, if you're asking yourself, where do I focus as an owner of critical infrastructure for the military, there's a couple things that you want to look at that go into that. So if you think about what General Chance Saltzman highlighted there, a critical infrastructure attack started with a cyber attack against ground systems, right? And that would be considered threat intelligence. So knowing what an adversary is trying to attack can help you understand what systems are being targeted by the adversary. So you want to first gather threat intelligence about the systems that are being targeted. And then second, you want to ask yourself, which of these systems are mission critical, right? So focusing in on the systems that are critical to the mission, because you can't protect everything. So step one is really to determine the most likely targeted national security systems. So if you're the Department of Defense and you're trying to get after which systems do I need to protect, you need to have two inputs. Threat intelligence, what is the adversary trying to target of my systems? And then which of these systems are actually the most mission critical? Because you can't protect it all. So you have to take a stepwise approach to focus on those systems that are most important to the mission. I'm going to move through this kind of fast because we want to keep it to five-ish minutes. And then once you know which of your systems are mission critical, in Department of Defense they call them national security systems, right? Then you have to ask yourself, which of those systems am I going to focus on within that mission critical system to get visibility, right? Because you can't protect what you can't see. In cybersecurity, you have to be able to see the assets to be able to protect them. If you can't see the assets that are on the network, then you can't figure out strategies on how to protect those specific systems. So if you think about a control system that's sitting on a fuel supply line, right, and that control system has a vulnerability in it, unless you know things like the model and the firmware version, you won't know if that system is specifically vulnerable. So after you've determined which of these systems are national security systems and mission critical, then you have to figure out how to get visibility into these specific systems. And on the left, there's just like a little graphic of a Purdue model of what you'd see in operational technology. You might have engineering workstations with controllers in that environment, and then those control systems might control fuel supply. So step one is to determine which are the most likely targeted national security systems, and then you need to get visibility. And you need to get visibility into the specific assets that control the specific mission critical function, whether it's fuel supply. You need to ask yourself, what does the system do? How does the system communicate? Where is the system located? And who is the system communicating with? The answer to all these different questions will help you get to the goal of closing, kind of just say it in the phrase of shutting the front door, right? If you think about a military installation and the adversary can't get in, you're reducing the attack surface of that. So the goal is to shut the front door. If you have a control system that's on the network, it has a vulnerability in it, the adversary can get through that front door potentially to cause some sort of desired effect. So the goal of this is to be able to see the assets so that you can shut the front door, determine what's vulnerable. I guess you do that by determining what's vulnerable, what's web facing. You can look at things like, is the process misbehaving? That could be an indicator of something bad happening in the environment. And the goal is to reduce the attack surface for your mission critical system so that it's tougher for the adversary to be able to attack those environments. And then once you've determined what your goal is, right? Because you always have the goal is to get visibility, but visibility for what? The goal in this case is to shut the front door, so reduce the attack surface for the specific assets that are on that network, right? Are those assets reaching out and touching the internet? Are they vulnerable to some sort of attack, right? And in order to determine this information, like you need to be able to have a fully enriched asset profile. Like I said, if you want to know if an asset's actually vulnerable on the network, you need to know the model, the operating system, and the firmware version of that specific system. But you don't just need to know if that system is actually vulnerable. You need to know things like, is that system exploitable? Is that system critical to the mission? And so, like historically, to gather this information about these operational technology assets, people have walked around with clipboards to try to gather that. But there's a way to automate this process. So step 3 is really to build a fully enriched asset inventory and network map for your operational technology and mission critical system environment. And there's a lot of people that claim to do this, but there's some methods and ways to do this well. So how do you actually get from just being able to see an asset where maybe you might have an IP address for that asset to getting all the information that you need to actually protect it? Where is that asset located? Is that system vulnerable? What is it talking to externally facing? So how do you do that? You have to pick a solution that does a couple things that, in order to do full visibility of these assets, to get a fully enriched asset profile, there's a couple things that need to be considered. One, the collection method, and 2, the protocols that you're analyzing. So the collection method, if you were to deploy a solution into your environment and collect information about that environment, you can autonomously or in an automated way build out these asset profiles. But to do that, there's different collection methods. Historically, there's one called passive, where you put a sensor on a network and you just passively collect the traffic as it passes by that switch that's on the network. Some more sort of cutting leading edge are like safe query, industrial safe query, where you communicate with the asset to determine what the asset is, what the firmware is. And then also project file analysis. So if you have a control system, there's usually a configuration file for that specific control system. You can download that configuration file, and then you can interpret or you can get insights from that configuration file to learn what that asset is, to build out that fully enriched asset profile. And then second, you also have to have protocols. So the number of protocols matter. So if you want to be able to understand what the asset is, and is that asset vulnerable, and who that asset is communicating with and why it's communicating with that, you need to be able to understand the language that these devices speak, whether it's SIP or Modbus or whatever. The technology that you deploy into your environment has to understand those specific protocols. And then it also has to be able to gain insights from those protocols. So it's the number of protocols that it can understand, and then how deep it can inspect those protocols. So that's just kind of a method that we think through when we're determining, like, how do we actually assess a network. So step one is determining which systems are national security systems informed by threat intelligence and mission criticality of it, and then getting visibility into those. What's the models, what's the vendor, what's the firmware, what's a fully enriched asset profile look like? And then in order to do that, you have to have good collection methods, and you have to have the protocols necessary to understand and interpret those. So that's how we would go in and assess what's on the network, so that you can essentially have that goal of shutting the front door. So that's it for today. Thanks everybody for joining.